Okay, in this exam, it looks like we have three different data sets. We have data on schools in Massachusetts, contact name, so the name of the principal, org code, unique identifier, type, location. Then we have data on school enrollment by grade and race, and then some data on test scores. First, we're supposed to create a relationship between the school's data and the enrollment data. So let's connect to the school's data first. And we see that there's the org code, the unique identifier, type of the school, the principal, address, school name, and so on. Let's make a relationship between that data and the enrollment by race and grade. Tableau could not establish a relationship by itself. That's probably because in the school's data, the unique identifier is in the column called org code. In the enrollment data, the unique identifier is under school code. Once we do that, the relationship is established. Now let's see how many observations do we have in the school's data. 1746. That makes sense. Well, sure, that makes sense, but there's 1700 schools, elementary schools in Massachusetts, public schools, it looks like, because the unit of observation here is a school. As identified by org code, school names, what do they look like? Yeah. Oh, no, this is, yeah, school name. Okay. Beaverbrook Elementary. Okay. So fine elementary school name. Let's take a look at the enrollment data. How many observations do we have here? 46,000. No, 43,000 observations. Well, do we have the same number of schools? Well, we actually have the same number of schools, 1746 rows, but for each school we have multiple observations. I wonder if those observations are by grade and race. And indeed they are. Once I add those two dimensions into the view, I have 43,445 rows. So the unit of observation here is school, grade, and race. Now let's see if the 1746 schools that we have in the enrollment data is the same as in the schools data. So let's put both school code and and org code, org code into the view, and no, not org type, org code. Set org code. There it is. And you see that, well, we actually only have 1,728 schools that match. All right, so there must be 18 schools in each data set that are in one data set and not in the other. Why 18? Because here we have 18 fewer matching combinations than if we put each org code by itself. We can also check that by adding in the count variables from each table. And we can see that here are the org codes that have observations in the school's data, one observation for each org code, but not in the enrollment data. Vice versa, if I flip the order, I see that there's again 18, this is 18 schools, the school codes that are in the enrollment data. We see I have multiple observations for each school code, but I have zero observations for these school codes in the MA schools data. All right, very good. One of the question asks if the school enrollment data could be described as stall data set. Yes, indeed. We saw that it had many, many observations, just a few columns. It could have been organized differently. It could have been done as each grade could be a separate column, or each race could have been a separate column. So that data set is in a tall shape. All right, let's start doing some visualizations. Create a horizontal bar chart showing the frequency of first names of school principals. Use function proper to convert names that are in all caps into properly capitalized names. What is the most common name? Okay, so let's do that in here. And we need the first name. Huh. So the contact name, let's see what the contact name looks like. All right, so it's Aaron Morris, Aaron O'Connor, and Earl Doe. So that makes sense. So there's always a first name space and last name. And we also see some fully capitalized first names, and we want to properly capitalize them so that if we have a Stephanie with proper capitalization and Stephanie with the all caps, they're the same Stephanies, and so we want them to look the same. So let's create a new calculated field. We're going to call it first name. And the first name is going to be, well, we're going to wrap it in a proper takes string as an argument. And the string that we want is we want the first part of contact name before a space. So that's what it should look like. Okay, let's see if that worked. All right, very good. Perfect. And here we actually see we successfully converted Stephanie very nicely. So let's just use the first name and let's do the count. So this is the school level granularity. Let's go from top to bottom. Michael is the most common first name of a school principal in Massachusetts, followed by John and Jennifer. Question 3, a horizontal bar chart showing the enrollment size of each 4-year high school, i.e. school with the lowest grade of 9 and highest grade of 12. Sort these high schools by size. How many are there? Okay, so we just need high schools. Well, so here's a school code. Here's a grade. You can clearly see that some schools have just grade 3, grade 4. Um, this looks like a school that's a proper high school. The minimum grade is 9 and the maximum grade is 12. So that's what I want. So how do I identify it? Well, I can actually create a new field that's basically the grade without it being a character variable, but being a numerical, so that then I can use the minimum and maximum filters. Let's do that. Let's create a numerical grade. I'm going to call it grade, and it's going to be integer of split of grade. The delimiter is going to be period, and I'm going to take the second part. Is that going to work? Yeah, it's going to give me 11, 12, and 9. Calculation is valid. I'm going to say OK to that. How do I check that it worked? Well, let's put the grade here, and let's put the newly calculated grade this way. Let's not do a sum. Let's do about average, because it's averaging across races, because there's a bunch of races in grade 3. So there's 3, 1, 2, Perfect. Okay, perfect. And the way I can now filter out proper high schools is I want only schools where the minimum is equal to 9. So the minimum is between 9 and 9. Um, and the maximum, wait a minute, no. Yeah, no, that works. And let's do grade. Um, and the maximum is 12, between 12 and 12. All right, no, no, so that's not what I want. Mm, I want the filter to be, yeah, I want grade. Uh, I want, yeah, I want the minimum to be, mm, between 9. No, I don't want, so I wanted this to be, I know why. I know why it didn't work. All right, no, I want the minimum to be between 9 and 9, like I said before. And I want the maximum to be also to be between 12 and 12. But I want to have this relay by school. Okay. So these are schools that meet that criteria because this is a summary level filter. Okay, so I'm filtering out schools by school code, and within each school, it's going to look, hey, what's the minimum grade? Is the minimum grade 9? If yes, it's going to be included. Is the maximum grade 12? If yes, the school's going to be included. Let's put in the school name, and we'll see these are high schools. These are definitely high schools. They all say high in them. Um, and they have a minimum and maximum grade of 9 and 12, respectively. I can actually check that. I can put the grade here and say, well, don't give me the average grade, give me here the minimum and give me the maximum. And that's exactly what I see. But what I was looking for is total enrollment for these schools. Um, as a bar chart, let's remove these um, minimum grade and maximum grade. We don't need that. We just want enrollment for each school sorted by from the highest to the lowest, and we see Brockton High as the biggest high school with 3,000 students, Ashland High 800, and so on. All right, very good. So this is question 3. Question 4, vertical bar chart showing shares each race by grade from kindergarten to grade 12 in that order. 13 bars, each bar with a height of 100% because we want shares split by race. So let's do that. We want grade in columns, and we want it in the order from K through 12. So I'm going to put K at the beginning, K through 12, and the height is going to be enrollment. And it's going to be split by race. And it's going to be a table calculation because I want shares. So I want a percent of total with a table going down. Yes, basically across races. Perfect. Let's actually duplicate this guy and put it on label too. Maybe I can make the label format it a little nicer with just zero decimal places. Okay. So clearly, we see most students, majority, are still white, but thing we notice is that grade 12, the share of white students is 57%. In kindergarten, it's only 51%. So clearly, the population is becoming more diverse, less white, mostly through growth of Hispanic population. Here, the Hispanic population makes up 26% of the kindergarten class, but only 23 of the graduating high schoolers. Share of Black students pretty constant, Asian pretty constant. So we see really growth in the Hispanic population coming down the pike. Nice. Let's do the next question. A filled map of zip codes where each zip code indicates the most common race of a K through 12 students. Okay, so we're gonna need our little helper table. Let's do this very quick. We're gonna do zip code, and we're gonna do race, and we're gonna do enrollment, and we're gonna do table calculation on that enrollment. We're gonna do not percentile, rank. We're gonna make it unique, and it's gonna be table across because we're gonna see which race has is number one in that zip code. Okay, so you see mostly it's white, but here it's Hispanic. Fantastic. We're gonna put this on a filter. Look only at number ones so that we have the combinations of. Oh, actually, I know how to do this. You can just select all and make it create a set. We're gonna say top race by zip code. Say okay to that. Now I can create a. I can double click on zip code, make it a filled map. Put the race on color and put my top race by zip code on filter. And I see, yes, most zip codes. The number one race is white, but there are a bunch of zip codes where it's Asian or Hispanic or Black. All right, very good. Mind you, this is a school, elementary school population. Okay, next we are supposed to create a dashboard. The bottom part shows a horizontal bar where each bar shows enrollment in each school broken down by race. So let's create that bar chart. So we want school. Let's go with school code. Let's also put in the school name, and let's put the enrollment as a column broken down by race. All right, fantastic. Um, we see the size of each school and the racial composition of that school. Now we can create a dashboard where I can take my map at the top and I can take my bar chart and put it on the bottom. I can, sure, maybe I can make this legend floating so that it's doesn't take all this space. I should probably zoom in on the map a little bit, maybe make it a little bigger. I could certainly edit it, but for the purposes of this video, I won't. I'm just going to add an action, and the action is going to be a filter action where we use sheet 7, which is our map as the source. It's going to run on hover. Uh, sheet 8 is going to be the target, and the fields that we're going to use is really just the zip code. Not the zip code and race, but just the zip code. So where is zip? I'm going to do zip here. I'm going to say OK. I'm going to say OK to that. And indeed, in the zip code, there's only one school, Hartwick Elementary. And in this zip code, there's a bunch of them. Okay, well, a lot of Hispanic because I just zoomed in on some you know, zip codes where that are not all green. All right, fantastic. That's our dashboard. Next question is symbol map. Symbols show the location of each school. Symbols are different color. That means we're supposed to zoom in on Boston. Okay, so the location. Now we've got X and Y, but X and Y, Temple thinks that it's just regular measures, but they actually have a geographic role. X has a role of longitude, and Y has a role of latitude, right? Longitude is right to left, latitude is up and down. So if I actually put these two onto columns and rows, I see here's the middle. This is the average of the longitude and latitudes of all these schools. Of course, I want uh, org code to be the detail, so I have all of the schools plotted. I want the in the size to be proportional to enrollment, but I also want the race to be on color, and that also is going to slice it up. So there's going to be multiple circles for each school. So the level of detail here is not just organization code, but it's organization code and race. If I zoom in on Boston, okay, let's make this map, maybe about streets. Yeah, that's nice. So you could see the um, kind of the suburbs and the center of Boston. Let's make these circles a little bigger, be even bigger. Let's make them a little transparent and maybe add a slight border to them. Or maybe not. Actually, the border looks better without the border. And I think I can make them a slightly bigger. Okay. This is very interesting. This is amazing. Show how striking the racial segregation of elementary and high school children is. South of Boston, mostly black. North of Boston, mostly Hispanic. The suburbs, Arlington, Newton, Dedham, mostly white, green. Very good. Next, we're supposed to create a horizontal bar chart showing average size in terms of enrollment of charter schools and traditional public schools. 2 bars. So we need organization type on rows, charter schools and public schools. And we need enrollment, average enrollment. So I'm going to do something that's wrong for now. I can exclude the null. Now, this is giving me average of the enrollment field. That's not, you know, 12, I mean, 15, 16, 20. That's not the average size of the school. That's the average size of a grade and race, because the granularity of the enrollment data is school grade and race. So I need something different. I need a calculated field. I need a enrollment by school. And that's going to be an LOD expression. It's going to be fixed at the school code. And it's going to be a sum of enrollment. I'll say OK to that. And let's put that here. Oh, and I don't want the sum. I actually want the average. Okay, now that's a different story, right? An average public school is about 500 students. Average charter school, about 600 students. Okay, very good. Final question is a relationship between MA schools data and MA MCAS scores. We still need to connect that MCAS scores. So let's do that under the data source. MCAS scores are here. And we'll again use the org code. It needs to be linked to school code. Fantastic. So just by the way, so the MCAS, how many observations do we have? So this is the count field. We have 303. Well, that's because it's just probably high schools. Is the unit observation school code? Yes, it is. Okay, so this is a school level data. And we're supposed to show here as a scatter plot of the share of white students in a school and the percentage of students exceeding and or meeting the expectations on this test. So we will need to calculate the share of meeting or okay, exceeding or meeting, and that's going to be basically the sum of exceeding um plus the sum of meeting. Actually, that whole thing is going to be should be in parentheses, divided by the sum of exceeding. Probably do it this way, plus meeting plus partially meeting plus not meeting. Yeah, those are the four possibilities, right? There's just exceeding, meeting, not meeting, and partial meeting. Okay. So, so if I put that in here, I see that on average, uh, 46% of, well, let's see. Yeah, so in aggregate, really, because this is an aggregate function. In aggregate, gee, only 46% or 47% of students are meeting or exceeding expectations. Now, we want to relate this to the share of white students. We want to see, um, how the differences in achievement vary across race. Let's actually just see how, if I put in the school code, actually I put this on columns and sorted, I clearly see, there's a school here with 94% students succeeding. Let's actually put the school name there, Boston Latin. And there's a bunch of schools here. Okay, well, this is zero. That have East Boston High School. They have 1%. Okay. And so this is all very um, interesting. There's these big differences in achievement, and we want to relate that to race. So we're going to create a field called share by race, and it's going to be sum of enrollment by divided by enrollment by school. Okay. Oh, sum of enrollment by school. So then whatever, if I slice things by race, right, it's going to give me the share of each race in each school or in aggregate. Let's just see how that's going to work. I just test it out. Here's my share. It's one, but if I slice this by race, clearly see, 53% is white and so on. So going back here, I want school code to be on detail. I'm going to keep the the share of exceeding or meeting expectations. I'm going to put it on rows. And I'm going to put my share calculation on columns. I'm going to put race on filter and just do this by white so that I can see just the share of white students. Okay. So if I'm um, and so I can see there are some schools like this one. Let's put actually name on school name. We can put school name on label. Let's use the entire view. Uh, and so these schools have mostly white students. These schools have mostly non-white students. If I put a trend line through this, let's see what that looks like. There's relationship here, right? It's clearly, these mostly non-white schools do poorly. They have low percentage of students who meet or exceed. And these white schools, yeah, they have a larger percentage of students who meet or exceed. There are some exceptions. Brook Charter School is doing really well. Boston Latin is doing really well. And but overall, this is pretty dispiriting chart that race plays a role in achievement here. So we can certainly format these things. I won't do that here. I'll stop the recording, and that's the exam.